is given as z cube is equals to z bar, where z is a complex number which is non-zero. Now we have to check the solution of this z. Now z cube is equals to z bar, so what we do is I'll multiply z on both sides. It will be z power 4 is equals to z into z bar. Now z power 4 is nothing but z into z bar is nothing but mod z whole square. Mod z is nothing but the magnitude. So if it is a magnitude, it is a constant. So we can say that z power 4 is equals to constant. Now z is the solution of this. Z power 4 is equals to constant, which is option C. Is nothing but mod is equals to 3 minus 2 minus 2. Now we have to find the value of median. What is the value of mean which is given as, mode is given as 18, that is equals to median, which we have to find minus 2 times of mean, which is 24. If we simplify, we have to get the median 22, which is nothing but option.
The energy of a body is increased by the action of external force. Work done in this case is, so when the force is applied externally, then the work done in this case is negative, and if the work is extended from the body, in this case the work is positive. So here the work done is negative and the correct option is B. Propeller shaft is subjected to maximum compressive direct stress 20 Newton per mm square and maximum shear stress of 18 Newton per mm square due to torque. The maximum tensile stress induced in the shaft is closed to. Here the options are 70, 60, 50 and 140 Newton per mm square. So here the given values are the maximum values, nothing but the direct stresses are principal stresses. That is, here the compressive direct stress is nothing but one principal stress and maximum tensile stress is nothing but another principal stress. So that we know that the maximum shear stress is equal to half of the difference between the principal stresses, sigma 1 minus sigma 2. Let us say here the compressive direct stress is minimum principal stress and the maximum shear stress is equal to 18 Newton per mm square. So here half sigma 1 minus of minus 20, so which gives a value of sigma 1 is equal to 140. So here the right option is D. Principal strain in a thin cylindrical tank having a radius of 25 cm as wall thickness of 5 mm when subjected to an internal pressure of 1 megapascal is. Here take Young's modulus of elasticity is equal to 200 gigapascal and Poisson's ratio mu is equal to 0.2. So we know that in a thin cylindrical shells there are two stresses induced generally. One is circumferential stress, that is called as the maximum principal stress, and another one is longitudinal stress, and that is called as minimum principal stress. So here the maximum principal strain is given by sigma 1 by E minus mu into sigma 2 by E. But we know that sigma 1 is equal to PD by 2TE and sigma 2 is equal to PD by 4TE, where P is the internal pressure acting on the cylinder and D is the diameter of the cylinder and T is the thickness of the cylinder and E is Young's modulus of velocity, and here mu is Poisson's ratio, and by using the given formulas we can write it as PD by 2TE into 1 minus mu by 2. So substitute all the values, all the given values. Here the internal pressure is 1 megapascal, that is 1 Newton per meter square, and diameter of the cylinder is 25 centimeter, that is 0.25 meters, and here thickness of the shell is 5 mm, that is 0.005 meters, into E is 200 gigapascal, that is 200 into 10 power 9 Newton per meter square, into 1 minus 0.2 by 2, and here it is 10 power 6, which gives a value of 2.25 into 10 power of minus 4 strain. So in the option, the correct option is A. A is the right answer. Of length 2 meter having dimensions of cross section is 40 mm into 60 mm. This beam failed by applying a force of 5 kN at the free end. The bending stress at the failure is given by, here the options are 470 Newton per mm square, 110 Newton per mm square, 209 Newton per mm square and 156 Newton per mm square. So here the bending stress at the failure is equal to, is nothing but the maximum bending stress occurred in the beam. So maximum bending stress occurs at where the maximum bending moment induced in the beam. So here the maximum bending moment for a cantilever beam carrying 5 kilonewton at the free end is equal to, so the maximum bending moment occurs at the fixed end, so that is equal to 5 into length of the beam, and here length of the beam is 4 meters, sorry 2 meters. 10 kilonewton meter or 10 into 10 power of 6 Newton mm. And the maximum bending moment stress, bending stress is equal to m by the section modulus of the section. Here it is equal to 10 into 10 power 6 by BD cube by, sorry, this is BD square by 6 and is equal to 10 into 10 power 6 by, where B is the 40 and D is 60 square by 6. So which gives a value of 417 Newton per mm square. So one in the option, the correct option is A. A is the right answer. Due to the application of impact load is, here we have some equations, but we know that the stress in the bar due to the application of impact load is always greater than or equal to 2 times the the stress due to the static loads. So here in the given equations, the only equation gives that is equal to greater than 2 times the deflection due to the static load. So that is C. C is the right answer for the given impact load. As shown in the figure 1, the frequency of vibration is n. What will be the frequency when the one more spring is added in series as shown in the figure? Here figure 1 having one spring with a mass m, and here figure 2 having two similar springs having mass m. And here the options are n by 2, n by root 2, root 2 by n and 2n. But here these two are similar springs, and let us say the spring of in the figure 1, spring of stiffness is K. K1 is equal to K, and in the figure 2, these two are similar springs, so that both are having same stiffness, K2 is equal to K. Now find out the equivalent stiffness for both the diagrams, and first for the first one Ke1 is equal to K, and for the second one Ke2 is equal to K by 2. So now we will have to find out the ratio of, frequency for the second diagram. So here for the first figure, the frequency of vibration is given by n and is equal to, and is directly proportional to generally root Ke. So when coming to the second diagram, equivalent stiffness is K by 2, and here frequency is directly proportional to root of Ke by 2. But we know that root Ke is nothing but n and by root 2. So here it is equal to n by root 2, and in the option the correct option is B. B is the right answer.